Alright, here is your video tutor session of Ensign class of Nomenclature. We're going to be naming the chemicals. Now our objectives are going to be using IUPAC symbols of the most commonly referenced elements. B, compare the characteristics of elements, compounds, and mixtures. C, we're going to compare characteristics of isotopes of the same element. Then going down into formulas and equations, we will interpret the information conveyed by chemical formulas for numbers of atoms of each element represented. And C, we will use the names, formulas, and charges of commonly referenced polyatomic ions. For this section, it'll be a brief overview of the periodic table and how we use it to name type 1, type 2, type 3, and polyatomic compounds. Now, as you can see here, I have highlighted this section in blue. These are the alkali and alkali earth metals. Over here, I call this the special six-pack in class. These two groups, you guys will consider these type 1. They are type 1 because they have the same charge every single time. If you notice, lithium, sodium, potassium, these guys are all plus 1. These guys will all be plus 2. And then these are plus 1, plus 2, and plus 3. Now, just to let you guys know, there are some other transition metals that have only one charge, but we will not be having those on the test or in the homeworks. Alright, type 2 metals come from this green section here, the transition metal section, as well as some of the metalloids. The reason why these guys are in a group, or considered type 2, is because they have multiple oxidation states. For example, if you look at iron, iron can be positive 2 or positive 3. And we'll get into detail about how you name those. And then these guys in the top right section, the nonmetals, they will be bonded with type 1 metals and type 2 metals. Their name will have "ide" at the end, but also these can make up type 3 if you have both of them from this section. So let's go into detail about type 1. Now, type 1 metals have the same oxidation charge all the time. What you do is you'll bond a type 1 metal with a nonmetal. To actually call it by name, you'll say the full metal name and then the nonmetal name ending with "ide." So, for example, if you have the formula here of NaCl, you will call it sodium chloride. Now, by the way, this blue section is the cation. This is a metal, sodium, and it's type 1. The name here is magnesium chloride. If they give you the name, you'll have to get the formula. This name is magnesium chloride. Magnesium has a positive 2 charge, and chlorine has a minus 1 charge. Now, in order to balance this out, if you have a positive 2 charge and a minus 1 charge, you will need 2 of the negative 1 chloride ions to make MgCl2, magnesium chloride. Alright, so again, type 1 comes from this blue section. They have the same charge each and every time, bonded with a nonmetal over here. And it's just straight up, you say the positive with the negative. Alright. Now, type 2. Type 2 metals can have different charges, like I stated earlier. To represent the value of the positive charge, you use the Roman numerals in the name. I, 1, 2, 3 going on up. IV represents 4. You think of it as V as representing 5, and if you put an I before it, it's 1 subtracted, and 6 and 7 going on up. Type 2 metals will be bonded with a nonmetal. How you name them is you say the full metal name, and then you give the Roman numeral charge, and then the nonmetal name ending with "ide." So, for example, if you look at the formula CuCl2, what you do is you have to look at what the charge of chlorine is. Now, we know that chlorine is minus 1, and there's 2 of them. So you would do minus 1, which means copper has to have a positive 2 charge to make this balance out. That's why it's copper 2 chloride. The Roman numeral is the charge. Let me say that again. The Roman numeral in the name is the charge. Now, if they give you the name like iron 3 oxide, it makes things a little bit easier for you. Iron 3 means that it has a positive 3 charge. And if you look up oxygen, oxygen always has a -2 charge. And so you'll have +3, +3, -2, -2, -2. Now, we've talked about the 3-2 rule in class. If you have a +3, you're going to need 2 of them. With a -2, you're going to need 3 of those. So the overall formula is going to be Fe2O3. All right, so again, we have copper here. Now, copper is in the green section. It's a transition metal. It can be either +1 or +2. In the case before, it was +2, and that's why we called it copper 2. And we knew that because it was bonded with 2 -1 chlorine ions. Okay? Alright, the next section that we're going to do is we're going to do type 3. Now, type 3, when you name these, the compounds will have both of them come from the nonmetal section, up here in the red. Now, type 3 involves 2 or more of the nonmetals covalently bonded together. By the way, when you have type 2 and type 3, these are ionic bonds, where the electrons are actually transferred. These guys are covalently bonded because nonmetals are normally negative charged, but when they can actually bond together by sharing electrons. Covalently, like a cooperative mission. If you guys play video games, right? Co-op, covalently bonded, they work together. Alright, so if you have a nonmetal and a nonmetal, what you do is you represent how many atoms of each element there are with prefixes. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca represent 1 through 10. Now, I like to remember these with a few different tricks. Now, mono, I think of the glassware, monocle. Di, I just remember as 2. Tri is tricycle. Tetra, like the game Tetris, each one of the blocks is made up of 4 little squares. Penta, like a pentagon. Hexa, like a hexagon. Or hepta just means 7. Octa is 8, like an octopus. Nona is just 9. And then deca, like a decade, it means 10. Now, one that you're familiar with, here's a formula here of CO2. Now, CO2 is the greenhouse gas. Carbon dioxide. Notice that the 2 here is represented by the prefix di. Also, do not use mono for the first element. Okay, so if there's just one atom or one element here at the beginning, you don't say mono carbon dioxide, you just call it carbon dioxide, okay? Now, I can also give you the name, and you'll have to tell me the formula. And then this is pretty easy. If it's dinitrogen, you know there's 2 of them. And then pentoxide, penta here means 5. So this is dinitrogen pentoxide. Now, when you guys are spelling these, watch out for prefixes where you drop the A and then bond it with oxygen. Notice that there is no A here, it's just pentoxide. Alright, so now you guys know how to name type 1 compounds where they come from the blue and bond with a nonmetal, because these guys are the same charge each time, +1 and +2, and then +1, +2, or +3. Right? Aluminum's +3 every single time. Type 2 is when they come from this transition metal section, and you have to tell me the charge with a Roman numeral. Type 3 is where they both come from here. You have 2 nonmetals bonded together, and you use prefixes like carbon dioxide to tell me how many of each element there are. Now, the last section is polyatomics. Now, polyatomics, like poly, meaning many, are groups of atoms that get together to form one unit. Now, there's a special section up here with carbon, nitrogen, phosphorus, sulfur, and chlorine where I call it the 8s, or carbonate, nitrate, phosphate, sulfate, and chlorate group. Now, you guys are just going to have to memorize these. What I like to do is I like to make a little section here. I draw that for you guys like this, where I section it all off. Now, if you want to see what carbonate is CO3. And that's an ion where it has an overall -2 charge. Nitrate is NO3 -1, and then PO4 for phosphate and SO4 for sulfate. So you got to memorize that all these guys have CO3, NO3, and ClO3, but these guys both are O4. Now, to memorize the charges, I just do a little jingle. I just say -2, -1, -3, -2, -1. It just helps me out. Hopefully it'll help you. If not, just memorize it and write it down again and again and again. Now, some other common polyatomics, where it's a poly meaning many ions grouped together, a common one is hydroxide. We'll use that with bases. OH -1. It's just an oxygen and hydrogen that are bonded together, and its overall charge is -1. Here's ammonium, and here's acetate. Okay? Now, polyatomics can be bonded with type 1 or type 2 metals. And if they're bonded with a type 1 metal, you name it the same way. It's just you add an 8 at the end. For example, if you have a formula of Na2SO4, you will call it sodium sulfate instead of, say, a sodium sulfide if it was just sulfur. The sulfate group right here comes as in one unit, and it has a -2 charge. That's why there's 2 positive 1 sodiums bonded with it. So that's sodium sulfate, straight up. Now, if you have a formula of CuNO3 2, that means you're going to have 2 nitrate groups. So here you can see the polyatomic was just written like normal, SO4. Here we put it in parentheses and put a little subscript after it, denoting that there are 2 of these nitrate polyatomic groups. Now, nitrate has a -1 charge, so it's -1, -1. Being that there's only 1 copper, you know that this copper has to have an overall +2 charge. So that means if this is a +2 copper, you'll call this copper 2 nitrate. Okay? Now, if I give you the name, say magnesium phosphate, you will have to memorize that phosphate has a -3 charge. Magnesium is +2 every time. So if you have a 2 and a 3, we know the 2, 3, or 3, 2 rule, you have to make it 6. So it's going to be +2, +2, +2, meaning that you'll have 3 total magnesium ions, and then -3, -3, meaning that you're going to have 2 phosphate groups. Now this is represented here by Mg with a subscript 3, and then PO4 with a subscript 2. And remember, they have to be grouped with parentheses, so you know that it's a polyatomic ion. Okay? So this is probably the most difficult group. I hope this video helped you out. We will be reviewing before the test.